and we believe that some of you guys are new to the session, and we have other people who are also in the session previously. So for those ones who are new, hang in there, and for the ones who are old, can we let the experience be an inspiration to the new guys? Thank you. I'll allow Casper to do the also.
Thank you so much, Cabello. Welcome everybody to today's session. We only have a few small rules again. We only want to ask everybody to please mute your cameras to save data and bandwidth. Also to mute your microphones to keep all the background noise to minimum. If anybody has a question at any point in time, please feel free to raise your hand or put it into the chat area. And then I think everything is ready. Over to you, Dr. Gous.
Awesome. Thank you very much. Thank you, team. Okay, so let's get started. I had a camera set up, but now I can choose either the camera or my voice. So maybe to explain, maybe we'll do my voice, and then I'll try something else. I'll test something else for tomorrow's session. So thank you, everybody. Thank you and welcome. As Cabello said, we are very aware that there are new coaches, and we'd love to walk a journey with you through science engagement. And we have a couple of faces that, or names that we recognize, but it's all good. It's all good. We can all work together. All right. So I'm going to do the presentation. I was going to do a practical presentation, but let me go through the theory quickly with you, and then I will open it up for discussion, and I will show you also the programming. Remember, now we've kind of bring together the programming and the building. So the building was session number 1, and this is our baby robot, the normal Riley rover, according to building instructions, which is really, I think there are 12 pieces in total, but really 2 motors attached to the brain, 2 wheels and axles, and it's very straightforward, very good for learning. You've got to start somewhere. And I've actually also got Mario here on the table, along with all my cats. But this is Mario, and so this is kind of where you want to go. You want to encourage and inspire your learners to come up with their own designs, okay? And it is doable. It is very doable. Here's some dog ears. We'll hear about dog ears in 2 weeks' time. I'll explain about dog ears. But I would like to encourage you just to start, just to at least start. We had in the previous session, Gunther was telling us they've started all their first-year students on Scratch Junior. We've got to start somewhere, and the sooner we start, it's if not now, when are we going to start? Okay, all right. So let me go through the presentation. Oh no. Next one. Let's quickly go through the presentation, and then it leaves enough time for us to have some discussion about the 2 topics. So there's 2 topics that I'm going to present. The one is navigation, and the other one is problem solving, and the 2 really fit hand in hand. Now I need to get my presentation. Here we go. All right, so I just need to make sure you can all see my presentation.
It's coming through now.
Yes?
Yeah, there we go.
There you go. Awesome. And my voice sounds normal.
Yes, I think it's just the microphone of the. As soon as you plug in the camera, it takes over that speed.
Okay, so I'm sure most of you already know who we are. I'm Patricia. I'm the presenter, and we've got as science engagement is Cabello, and then through communications, Anzani, Tumelo, Nadine, whose voices you've heard. And then Casper, you've heard his voice, and Anzani, she's doing the analytics for us, and she'll explain. We want a richer analytics for this season, so she'll explain that at the end of the session. All right, some navigation information for you. The content and the recordings will all be on the iSet Robotics MOOC M1 portal. Tumelo and Nadine are happy to answer any of your MOOC queries. Send them an email, and they'll even have a one-on-one session with you if you really are stuck. But the basics, the sessions are available, and the site is iSet Robotics M1 2022. All right. Just maybe as an aside, it's a lifelong registration. So as long as the portal is alive, you are connected, and so you will be able to use that as a repository. We're going to add a whole lot of activities and materials which you can then freely use in your teaching and learning. All right. And the the M1 overview document has got enough teaching information. So you can do Unit 1 is the building. There's a lot of building opportunities there. Number 2 is the programming. And then number 3 is what we're doing today. Okay. So really welcome. It's Unit 3. So we're past halfway mark. So well done. Well done. And these are just the general class culture. We want to equip our robotics coaches. It doesn't matter whether you're a student, a facilitator, a teacher, a visionary community leader, but please ask the questions. And that's the link for the MOOC portal. All right. We are going to go from basics to beyond. We're going to get there, but we need to start somewhere. Okay, so my picture, if you could see my face, I've always got my 2 hands up. On the one hand, we've got the build. We need to actually build a robot, or virtually or physically. So we've got the toolkit or digital designer or studio, whatever you want to do to build a robot. And then we need to program it. So we need to make it do something. And in between are these 21st century skills that our learners need. Okay, and we're going to start with motorized robots just because that is where we start. The Riley rover has been the ISET team's kind of go-to robot now for a long, long time. We're probably going to have to go to a Spike robot, but for now we'll stick with the Riley rover, and because you can do so much with that design. Okay, so just for those who maybe are not aware, these are the 2 different kits that we use. The one is the EV3 Mindstorms kit, and this is the core set, the education. I don't know, it's a bit blurred. It's the core set, and this is the Spike Prime core set, also with sensors, motors, and then the brain. Brain's a little smaller, but just as effective. Okay. So robot navigation is actually a very big topic. And you will see if you go online and you go and look at robots, robots need to know how to move in their environment. Okay. So if you take, for example, the little Mars robot going around on Mars, it needs to know when there is a donga. It needs to know when there is a hole. It needs to know when it goes up, when it goes down. It needs to be able to see in inverted commas. And so you can program your robot to read the environment. And for now, our environment is just, well, it's just a robot. But I would really encourage you to go and see what other definitions of robot navigation there are. Okay, so one of the key issues of robot navigation are sensors. Okay, and then odometry is when you use this data, this sensor data, to move your robot so that your robot knows where it is and where it's going. Okay, there's a list of robot navigation techniques that can be used by robots. I want you to go and have a look at that. And an autonomous robot is one that can make its own decisions. So if it comes to a line, say on a road, it will stop. Okay, and if it sees something, an obstacle in front of it, it'll not ram into it. It'll make a plan to go around it. Now, that is not because the robot is very clever. It's because your programmer has programmed the robot to do such. Okay, so autonomous is a robot that can navigate. And so the next topic after autonomy is artificial intelligence. Okay, and so that, just keep that in mind. We've got to start somewhere, but for now we've got a really senseless robot, and we're going to do navigation with a senseless robot. Okay, so in between having a robot that you can program and a robot that you can build, there is some problem solving, because problem solving are the steps that you need. And it's normally you here and then you've got to go there, or you're here and you've got to do this. And I think that one of the biggest reasons why problem solving skills are important is because you cannot teach them, you develop them. You have to develop your problem solving skills. It is not okay for the learners to put up their hands and say, I can't do this, and then they go and look at the back of the textbook, because life's problems are not in the back of any textbook. Okay, gratefully, there are a number of steps with problem solving, and there's some techniques. My favorite one is brainstorming with lots of paper and pens, and then you put down all your ideas and you solve the problem. I think that the greatest technique that learners can realize is divide it up. Divide up the problem into parts, and then slowly but surely you will get to a solution. All right. So it's a lot of theory behind today, but hopefully you'll get. All right. There are a whole lot of activities in your overview document and on the MOOC portal. We're going to see how many activities you can complete. But these are, so if you would think, what are the steps that you will need for the robot to draw the first letter of your name? Well, I would definitely say, draw it with your finger. So you go forward. So if my first letter is a P, so I've got to go straight. I'll show you just now. So you've got to go straight, and then that P is your robot's got to turn the corner. If you've got an S as your name, you've got to turn multiple corners and change direction halfway. Right. We'll come back to these activities. And sometimes it's good first to talk it through. What must your robot do if it must go in a circle around a bucket? Well, hopefully it'll stay clear of the bucket, but it's got to keep going kind of round and round and round without touching the circle. That's just how it is. All right. Okay, so the problem about problem solving, it's one of those 21st century skills. It's practice. It needs practice. And there are quite a few resources out there to encourage problem solving skills. Building puzzles, doing games, playing games, as they're all problem solving. Okay, it requires practice. There's no in the textbook answer, I promise, but it does require patience and perseverance. And there might not be only one correct answer. Okay, so I've just got teach in inverted commas. We don't teach problem solving skills, we develop problem solving skills, and that needs time. Okay, that's again, it just doesn't happen overnight. But it's got to fit into, it's like a puzzle piece. It has to fit in into the bigger picture. All right. Please don't memorize the correct answer. Please do not get your learners to memorize a design or to memorize a piece of code. They have to understand what the problem is and what the solution is required. Okay. And you have to know where you're starting. So where you're starting, you define your context. All right. So here we are. Where are we? We have a robot. Robot can move. Unfortunately, you can't see it on my camera because this camera doesn't work. And just the PS, we'll get to it in the 2 weeks' time. We can do a whole lot of touch sensors and ultrasonic sensors and color sensors and blah, blah, blah. We'll get there. But for now, we just got a little robot that can go forwards and backwards and round the corner. Okay. All right. So you always solve a problem with what is given and then what is required. And remember, we're only doing navigation for wheeled robots. So it does have wheels. It's not walking anywhere. It's not flying anywhere. It's just with wheeled robots. Okay. So navigation is always, where do you start? Where do you end? And what is this problem that you need to solve in between? Write it down, draw pictures, make diagrams, make sketches, whatever it takes to understand what the problem is. Okay, so this is a problem-solving methodology that Tanya Karp brought to us about 5 years ago. Yeah. So it's thinking like an engineer. So it says you sketch something, then you write down what the objectives are, then you list the variables and the equations, and then you manipulate it and you get to a solution. All right. Okay. So let's just go for a really simple problem. You've got to move your robot straight the distance, and so you've got a start and a stop, and you've got a distance in between, and the robot must move forward. Okay, it says forward. All right. All right, so you will know, well, it doesn't say whether it must go forwards or backwards, whether it can reverse. And in theory, the speed doesn't matter. I mean, if you go slowly, you're going to get there. All right, so what does matter is your robot's size of its wheels. And I'll show you now an easy way to measure the wheels. And then it must brake when it stops there. And so each rotation is the circumference of a wheel. So you've got to obviously know what the circumference of your wheel is. All right. So let's go. The distance we've got to travel is 50 centimeters. And then I've taken a piece of ribbon and I've tied it around the wheel. And then I've put it onto a ruler. And I see the circumference is 17.8 centimeters. And I do my calculation. And I see, oh my goodness, we have to do 2.81 rotations. Okay, so there's your answer. You put the robot down. You run a program to go for 2.81 rotations, and then you make the robot stop. Okay? Ta-da! Okay, so this robot goes forward, B and C. Both wheels are going with 20% power. A little bit slow, but it's good. We're going to go forward, and we're going to go 2.81 rotations. Okay, just as a matter of interest, this is a move steering, and a move steering allows you to set both wheels onto different power settings. You must just be very aware that you have both at the same power. Otherwise, you're not going to move forward. Otherwise, you're going to go in a circle. Okay, so let's just unpack this a little bit more. All right, we are going to now change something. We're going to change the power of our robot, and let's see whether it impacts on our speed. Okay, so speed. How do we measure speed? Well, we can't really measure speed, but we can measure distance and we can measure time. And you know, there's a formula for that. So speed is distance over time. Great stuff. Okay, so now we can measure the time with the stopwatch. We can measure speed, distance with a ruler. I know that there's a time where it accelerates and it slows down at the end. I think if you're going slow enough, that will have minimal impact, but it's a good experiment to do with our grade 8s and 9s. They do the graphing of these things. There's somebody's microphone just unmuted. Okay. All right. So, and then we need to do the experiments with a whole lot of power settings. All right. Okay. So we get our list of variables here. Sorry, somebody's unmuted. Okay. We've got our variables. There we can see we've got a calculation. All right. We've made the distance a little bit more, and we're going to do different power levels. Okay. And then the time, well, we can measure that with a calculator or a cell phone, and then we can calculate the speed. All right. So we're going to work it out here. Then we've got the number of rotations is distance over circumference. So we've got to do 8.43 rotations, a little bit further than we had. And then we're going to change the power setting at each time. So we have our little table, and we say for power setting T, let's run it. And you run it. You say how long does it take? And then the distance stays constant, so we can calculate speed. Then we take 20. How long does it take? Measure the time. Then we can calculate the speed. We do that for all of them. Now you're assuming that the greater the power, the greater the speed. I would also assume that. Okay. But there's a whole range of navigation problems. Can you see that we can move forward, we can stop, we can turn, we can go left, we can go right, we can turn around. But these are all the problems. So a good one is to have a robot go forward, round the water bottle, and then it's got to come back to base. All right. How would you do that? And it's got to avoid the water bottle. Go forward until it touches something, and it may not tip over something, and then it's got to come back. All right. Each problem. Okay. So where is this going to? Well, in robotics, there are a number of problems that you can solve. We've done a whole lot of projects, problem projects. We did that end of last year, I think. But every robotics competition has got a whole lot of missions that you have to do. And so the team needs to look at these list of missions and say, okay, so how do we solve them? What is required? And normally it's about looking what the verb is. Push or pull or fetch or collect or drop. What is it? Okay, so the previous example was travel. So we've got to go from A to B. Adaptations on your building instructions, that's what we're going to do tomorrow. There's lots of programming examples, YouTube videos, and online tutorials, all right, to get some inspiration, to get some ideas. Okay. I've added here a number of articles, and I would love to include from South Africa, but these are news articles of using robotics, and it's not to teach, but it's to develop problem-solving skills, which is great. Okay, so maybe you can get some ideas from these examples. The other problem solving that you as the coach need to know about is that very often you're going to be in your class with a whole lot of learners, and somebody's robot is not going to work. All right, so I would really recommend that you watch this video, Dr. Hino's problem-solving process, that you have a kind of a frame of reference if your teams come to you and tell you, man, the robot's not working, okay, or the robot's going skew, or the robot's not moving, or there's a whole lot of generic problems that robots have, least of which is the battery's not charged and the cables are not in the correct ports. Okay, so watch these 3 videos. You might get some inspiration of how you need to function in a robotics class, because you need to have all the answers for your robotics team. Okay, so that is in a nutshell how we solve problems, and I'd really like you to complete at least up to Unit 3 on the MOOC 1 portal, and then solve some of the navigation problems. See whether you can first decompose it, so write it as a solving problem, and then to actually write the computer program and to build a robot that will solve that problem. That is a bit of a challenge. All right, so that is your challenge for this week, is to get a robot to do something. Okay, and then tomorrow I'm going to ask, do you have any MOOC questions? Would you like to give an overview of the MOOC? I don't know that Tamila's in the session. All right, that's it. All right. So now I'm going to stop talking. I'm happy to answer any of your questions. I'm happy to listen to your suggestions. I've got a robot here, and I can show you. Maybe I should just quickly. All right. So just one of the problem-solving things is we don't believe that our learners realize what the link is between the circumference of a circle and the distance a robot travels in one rotation. So I've got a ribbon here, and so to decide how far this robot's going to go in one rotation, what I normally do to demonstrate the purpose, I put it around here, and then I close it, and then I measure this distance, okay, and then I take this distance and I put it onto a ruler, and it's like 17.8 centimeters. Then I know what the distance is, how far the robot's going to travel in one rotation. So if it's got to travel 35 centimeters, then it needs 2 rotations and maybe a little bit. Okay, so it's about making the problem-solving process understandable. That's what we want to do. Okay, so that's, I always have a ribbon with me, because these tape measures tend to go missing very quickly. All right. Yes, and so we have to write the programs and then download them onto the brick and then test them to solve the problem. Okay, I suspect we might need a couple more sessions on unpacking problems, but if that's what you need, you're most welcome. All right. I'm going to ask Cabello, are there any questions on the chat?
Nothing. It's just a greeting.
Oh, just a greeting. Okay. Okay. Nothing. All right. So I'm going to. I will quickly share my screen. I'll show you how we're going to program this robot to go forwards and backwards. So just to show you how the program works. So if we go onto here and we share our screen as usual. There we go. All right. Can everybody see my programming canvas?
Yes, we can.
Okay,
Yes,
thank
yes.
you very much. All right, so this is, let's just say we wanted to test the program must go, I don't know, it was 2.81 rotations forward. All right, then what you will do is you will say move steering, because we've got both our motors. So we move B and C, and we say number of rotations is 2.81. All right, you can set the power there, that's 50. For a forward motion, it's probably all right. But if you're going to go around a corner, I would say 30 is around the corner, and you can see here it's going straight. Okay. And then just for good programming things, I would always put motor resets for both motors. It's like you just ready, steady, go. So let's just reset our motors for B, and we can change that port for C. And so if I, over here at the bottom here, me just show you on the port view over here. Okay, so here I can see I've got two motors, a motor B and a motor C. Both are large motors, you can see over here. All right. Now I have, let me just have a look. Okay, so that's my firmware. I have connected there, can you see, with Bluetooth. All right. So you can either download the program with a USB or you can download it with Bluetooth. There are three download options. The one is download. The one is download and run, and the other one is when you do just the selectors. So if I were just to select, can you see there's a blue line around there? That would be just selected. But either way, I have seen too many robots smashing to the ground. Okay, so what I'm asking you to do, and I'll show you now on the screen, is to do download. You download it, and then I'll show you how to find it on the brain. What learners do is they do download and run, and the robot is standing at the edge of the table, and before you know it, the robot's on the ground and shattered. It's just not worth it. All right. So now I can't share and show you, but basically what the robot's going to do, it's going to go forward. Okay, so you can, well, haha, this is a weird thing. Okay, so if we're going to download, you're going to hear it goes forward. There we go. Can you see it's over here? You can see on the top when the program is working. All right. So now it's gone 2.81 rotations forward, but now we want it also to come back. So because of momentum, we always put a weight in between. If you're at a competition and you don't have 1 second to wait, well, half a second is better than nothing. All right. And now we want to come back. All right. So here we're coming back. If we go 2.81 forward, we've got to go 2.81 backwards. And now we've got to come backwards. So if it's positive power is forward, then negative power, negative 50, is then you can see the arrow changes. And so then we go backwards. So if I then download it and run it, it's going to, can you hear? It stops, and then it goes backwards again. All right. A good idea to solve problems, especially if it's longer programs, is to put a just mind this thing out the way, is to put a sound in. And I can tell you that it gets quite loud, but it also uses up, it delays your robot with the sound. So sometimes it's not so great. Let's just go. There we go. So you'll know that your program ends. So here we go. If we can now going to download and run, it's going to go reset, forwards, stop, back, and the snake. All right. So navigation, that's your navigation. If you wanted the robot to go around a corner, then you would take maybe this out. Let's just take that out, and we're going to use a single motor. And the single motor would then be just a rotation to go, and it'll turn the robot to one side. So if B motor is turning, it'll then turn towards the right. Okay. Anyway, that is made any helpful. Let's hear your comments. Okay. Anybody got any questions? Are we all good with navigation? Are we all good with problem solving? I think the underlying thing is you have to practice. Find a whole lot of activities and just do the activities one after the other as programming activities. And then you will kind of understand. You will definitely do problem solving. Last year we had a lot of fun with writing names in the, with attaching a cookie on the side of the robot. It was a lot of fun, but a very necessary exercise in most of the alphabet. All right. Anybody's hands up? Anybody got questions?
Ladies and gentlemen, if you have any questions, kindly please raise your hand. Or there we go. I see Nadine has a hand up.
Hi, Nadine.
Hi, just a question about the version of LabVIEW you're using. Is it an existing one you had on your computer? Or
okay, I'm using EV3 Lab version. Yeah. It has been on my computer.
Does it look the same, or can you still download that version? You
would probably not be able to get this version.
Okay.
You'll probably need to download EV3 Classroom,
Okay.
which replaces the EV3 Lab and the EV3 Programming app. All right. Okay. Thanks, Nadine. When I get my new laptop, we will see how it works, okay? Because then I stop using this laptop. Awesome. All right, anybody else? Are we all good? Are we all good to do programming? I was actually going to show you a mat. It's good to have a whole lot of programming activities and get your learners just to do the basics. Go forward, go backwards. There's a really good activity if you say do 10 rotations, 10 degrees and 10 seconds, and then you say which one goes further. Learners don't always grasp the concept that 3 seconds is not the same as 3 rotations or 3 degrees. 3 degrees and 3 rotations are definitely not the same thing. And that is also one of the points of error. So if I can just share my screen again. This is one of the things that we often, that I encountered with when I was coaching. So these learners would then give this, and then they would put this to 0. All right, so it's 0, and then they wonder why the robot doesn't go anywhere. Okay, or they make this 0, and they wonder why the robot doesn't stop. Okay, these are the kind of things that you'll pick up as the coach. Yeah, and then going around a corner at 100%, there's going to, if you're going to go too fast around a corner, you're definitely going to get slippage. And we don't want inaccurate robots. We want robots that can consistently do the same program and land up at the same place. And so this is the good habits that we teach them to start off with. So we reset our motors, and we put pauses and waits in between all our code, especially when we're changing direction. Right, and lots of noise, but in the testing, in the debugging, and then but for the final program, you can take out all the noises. You don't really want a noisy robot. No. All right. Okay, then I think we're done then. If there's no further questions, everybody's good. Everybody's understanding, and everybody's going to be programming. So maybe for tomorrow, come and share some of the programming that you've done today, if time allows. Okay.
Sorry, Dr. House.
Yes.
I've got some few questions on the chat.
Oh, okay. Awesome. Good.
I see Little King from Rustenbeck says, good afternoon, Dr. House. I hope you're well. We didn't find the Unit 1 video on the MOOC portal, and Unit 2 only had EV3 videos, and currently we are using Spark Prime robots. Will the videos be downloaded on the MOOC portal?
Yes, they will all be uploaded over the weekend. The recordings will be uploaded on the weekend, correct.
All right. And then Lungi's gift says, cannot see the robot. I think, Lungisa, you just have to go through the recordings that will be loaded.
Okay, yes, you could not see the robot because the camera that I was using was distorting my voice.
All right.
So I will work on that tonight so that we have a surround sound for tomorrow's session. Okay.
I see one of the most active participants, David, says it's very clear and was easy to follow. Next step is to do practically.
Yes, absolutely.
Specific says, how do you reset motors in Spark Prime?
How do we set the motors?
Reset.
Oh, reset. I'll come back to you on that one.
All right. And then, yeah, so far it's thank you, and thank you on the comments.
Okay, cool. Yes, the team is going to do, I think that's what we're going to do on Monday, team. We're going to play with Spike Primes. Okay. I think that's what, with lots of Valentine's chocolates and flowers and all kinds of things. Bill.
Anyone who still has a question, feel free to ask on the chat or raise your hand or unmute yourself. I see Palisa says, thanks. She managed to log in on the MOOC.
Oh, that's good news. That's awesome. Well done, Palisa.
So far, so good.
So far, so good. All right. Okay, then we are all set to go. Thank you very much. Kabela, would you like to? Oh, Anzani, you've got a moment.
Yes, thank you for Patricia. Thank you for remembering me as well. Guys, thank you very much for joining us. And then on my side, I have a link, a Google Forms link, which I just sent right now. So what I would love for you to do is kindly complete the form. The reason for the form is that we are trying to have not accurate per se, which because it's kind of impossible, but we're trying to have accurate stats in terms of how many people are joining our live online sessions. So you would find that per account or per account it would be one person, but behind the scenes there'll be 4 or 5 people logged on. So we're just trying to see, I don't know if I'm making sense.
Yes, perfectly. Yes.
Yes. So we're trying to understand how many people are joining us, because according to the session now, there's about 33 people joining us, when in essence there's probably 60 people without us knowing. So it's just a questionnaire, about 5 questions, 4 or 5 questions, just asking you how many people have joined. So yeah, that's about it. I would love for you guys to actually participate on that Google form.
And you've got the form link up there. It's coming. All right. I wonder, whilst the Anzani is posting the Google form link, we had really cool news during the previous session. Nadine, would you like to post that link again? The news link.
Sure.
Thank you. Thank you. We had some really good comments in the previous session. Nadine is our news department, and so she's found some good news in terms of robotics. Maybe that motivates you also to see why we are equipping our learners for a future that's really unknown. Thanks, Nadine. We're just waiting for the 2 postings. Anzani, you're going to, there we go. So Anzani's, there we go. Whoa, that's come through quickly. So Anzani's link is there on the forms at 4:37. And please fill that in. We'd love to hear, even if you just want to give us some feedback, that'll be great. And then, okay, Tamelo's going to share his screen. Thank you, Tamelo. Nadine has shared the link. Nadine, you want to chat through it?
Over to you, Nadine.
All right, so Neuralink, if you don't know Neuralink, it's Elon Musk's, one of Elon Musk's companies that he's co-founded, and they have a brain interface technology which they've created in the form of a microchip, which can be implanted into animals and now human beings. So the first trial was actually has already begun by the rival company called Synchron, and the first implant was surgically implanted into a man, not in his brain, and he was able to tweet. So the first successful, the first trial succeeded in a tweet from his mind. So he tweeted, and I will actually keep updates on that and post news related to that.
Awesome. Awesome. It's life-changing. It'll be life-changing for a lot of people, I do believe. Yeah. Nadine, is there anything about for deaf people?
Well, the technology is seeking to study the neural patterns of the brain. So
Oh, wow.
We have
Sure.
neural networks in our brain. It works like wires. in a network. And if this technology can study all the aspects of the brain, such as, like, we can call it the highways of the brain, then it's able to imitate the human function. So that is why they are testing it on people with disabilities to see what benefit it can have for people.
Wow. Wow.
So there are plans to test it on people with glaucoma, which is an eye condition as well.
Yeah, yeah.
Yeah.
Imagine seeing for the first time when you are already middle-aged or older. Wow.
Yes.
Wow, wow, wow. Thank you so much. Thank you for that. And thank you for sharing your screen, Tamila. I love this teamwork. It's really cool.
You're welcome.
Really cool. All right. So on that very newsy and inspired note, I think we're going to close. Okay. Kabelo, are you still in the session with us? You want to close for us, please?
Thank you, everyone, for attending today's class. We truly appreciate each one of you for attending. And together we can only build this community. And as I said, that the experience one be an inspiration to the guys who are joining for the first time, and we can only build this community together. Thank you. Until we see each other tomorrow. Bye.
Thank you, everybody. Thank you, team. It was awesome. We'll see each other tomorrow, shall we? Thank you.